Hey Code Crew, welcome to the full stack iOS Notes app, where you'll not only be building the iOS app this time, but you'll also be implementing the database and the API. Now I don't want to reveal too much because this app series is going to be led by a guest teacher who will walk you through how everything works. His name is Ali and he's been working with us here at CodeWithChris for the last couple of months. I'll let him introduce himself.
Hey guys, I'm Ali and I'll be showing how to make this really cool Notes app. So let's just get into it. I'll start by showing you the interface and I'll explain the different parts of the apps once we get there. So to begin with, we have our Xcode project, which is just the iPhone app itself. And I can add a new note, so I can write new note. This is the first note, and I can save that. And I can add multiple notes as well, so this is the second note, and second note. And it'll save the date as well with the title and the actual note itself. And this is all being saved to a database. So if I restart my app, so if I just go in and close my app and open it again, we can see the notes are still there because it's saved to a database and not the device itself. And I can also update notes. So if I click on the note, I can say this is second note updated. And if I save that, it'll show that this is the second note which has been updated. And I can also delete notes. Just click the delete button and it'll delete notes. Now the cool thing about this is the actual database is not core data or realm, which is what you would expect for an iPhone app. In fact, we're saving to MongoDB. And how that works is I actually have a server running, and this server is running on my machine. And what happens is the iPhone contacts the server to save the data, and then the server saves the data to the database and tells the iPhone that it's saved. And I can show you how this works in real time. If I make a new note, test, and if I save that, it'll show on my iPhone. And then if I go to my terminal, if I use the Mongo, and I'll show you how this actually works later on, but I'll just show you the actual data which is being saved in the database. If I say show DBs, use new DB, db.datas.find, you can see that this note has been saved on my local machine, which is MongoDB. And I got the note here, I got the title, and have the date. So I'll show you all how the different parts work, and we'll actually get started with installing the actual dependencies like MongoDB. And once we've got that done, we can start working on our actual app. Alright, so before we start working on our actual app, I just want to take a quick second to look at how the architecture and data flow of our app will look like. So our app is going to have two main routes, and routes are just functions. So for example, we're going to have a route or a function to send something to the database. We're going to have a route or a function to retrieve something from the database. And how this is going to work is that we're going to have our iPhone, which uses Xcode and Alamo Fire, and that's going to send what the user has entered in their text field to the server. The server, which is made with NodeJS, express.js, and Mongoose, will then process that data and save it to the database, which is MongoDB. Then the database will tell the server if it's saved or not, and if there were any errors, and the server will tell the iPhone if it's saved or not, and if there were any errors. And that's all the first route is, and that allows us to save something to our database. And the next route we're going to be working on is retrieving something from our database. So we want to be able to see all the entries in our database and display on the iPhone. So the way that's going to work is that we're going to have our iPhone, which is made with Xcode and Alamo Fire again, and that's going to actually ask the server for the information now. So last time it was sending data, but this time it's just asking the server to send everything back. So then our server is going to look through the database and it's going to take out all the entries. And once it has the entries, it's going to send it back to our iPhone. And then our iPhone will refresh itself and we're going to see the new data that we've entered in our database. So those are the two main routes, sending something and retrieving something. But we also need to make routes for updating and deleting. But those routes are more or less just variations of these two routes. So once we have these two routes down, it shouldn't be too hard to get those working as well. Alright, and now the last thing I want to do before we start actually working on some code is just giving you a quick lesson plan of what the different things we're going to do in this video series are. The first thing we want to do is actually install all the dependencies for our project like MongoDB, NodeJS, express.js, and Mongoose. And after that's done, we're actually going to start building our server. So the first half, we're actually going to start writing the code to build our server and make sure our server works. Then what we're going to do is we're going to test our server using an app called Postman. So that just allows us to test our server without having to make our iPhone app first. So once we know our server works successfully and we can update items, delete items, create items, and fetch all items from the database, then we'll actually start working on our Xcode project. And in our Xcode project, we're actually going to be making our app and making our app communicate with the server. And we're going to use Alamo Fire to make the app communicate with the server and make sure that the user then can add entries, update entries, delete entries, and fetch entries. And once those two things are done, our app should be complete and we'll have a final product of the finished Notes app. So before we actually start writing any code, I just want to take a quick second to look at the different tools we're going to be using and what they are. So the first thing is our database, which is MongoDB. And MongoDB, it says, is a cross-platform document-oriented database program, and it uses JSON with optional schemas. So what that allows us to do is save our data in a format which is called JSON, and that's the exact same format as when you work with the API, for example, and you fetch some data, it'll return it back in JSON. So what this means is that when we actually want to access our data from the database, it'll make it super easy to be able to access and work with the data we saved in the database. And the other reason MongoDB is super popular is because it's really light, it's easy to get started with. So that's MongoDB, which is our database. And the next thing is Node.js. And what Node.js is an open source cross-platform JavaScript runtime environment, which allows us to execute JavaScript outside of a browser. And that's really what Node.js does. So usually, for example, if you go to your inspect, you can actually run JavaScript inside your browser. So I can do like console.log hello, and it says hello right there. So I've actually ran JavaScript inside my browser, but to run JavaScript outside of your browser, you actually need something called Node.js. This will allow us to run JavaScript on our machine to create a server. Then our iPhone can interact with that JavaScript we wrote to send and receive data. So that's all that Node.js is. It's just a program that allows us to run JavaScript outside of the browser. And to actually create the server, we're going to use express.js. And what express.js is a web application framework for Node.js. So Express runs inside of Node. So Node runs the JavaScript, and Express is what we actually use to create the server. So we need to create routes or functions, for example, to add things, fetch things, update things, and delete things. And the way we're going to define those functions and the data they take in and give back is using Express.js. So Express.js will make it super easy for us to actually create those 4 functions and create our server. And the last thing we're going to be using is called Mongoose. And if you go to the actual documentation for Mongoose, it says Mongoose provides a straightforward schema-based solution to model your application data. And that's really what Mongoose does. It just makes it super easy for us to first create our schema or actually define what our data looks like. So for example, our note has a title, a date, and a note. So it makes it super easy for us to define that object. And it also makes it super easy for us to interact with our MongoDB database in our actual Node.js file. So without Mongoose, it's a bit harder to save data or update or delete data, but using Mongoose is super easy to interact with our database. Alright, now that we've got that done, let's actually start working on some code. Alright, now let's get started actually installing the different stuff like MongoDB and Node.js. And as we're installing it, I'll tell you what it actually does and how it works and why people use it. But before we start installing any of those things, we need to install something called Homebrew. So if you just Google Homebrew, it says Homebrew is a free open source software package management system that simplifies the installation of software on macOS. And that's really what Homebrew is. It just makes it way easier for us to install different things like MongoDB and Node.js and different software packages like those. So instead of having to unzip files, run installers, all that stuff, you can install packages with a single line of code. So if we go to the Homebrew website, you'll see it says right here, install Homebrew, and there's one line of code. So all you have to do is copy this line of code, and then in your search bar, just search for terminal and click open. And once your terminal's open, you can simply paste that one line of code and enter your password. And then click enter, and it'll say installing and downloading Homebrew. So just give it a quick second and it should work, and it'll tell you installation successful. So now we know that Homebrew is installed, we can install different things like MongoDB and Node.js with a single line of code. Alright, now that we've installed Homebrew, we can start installing things like MongoDB. So if you just Google install MongoDB Homebrew, and you click on the first link, it'll say install MongoDB Community Edition on macOS. So just click that, and it gives you the instructions here. But before we start installing, let's just get into why people actually use MongoDB and what it is. Well, MongoDB is a database, just like you have core data or any other type of database. But what it does, it stores data in a JSON format. So if you ever worked with the REST API, you know it returns back JSON. So MongoDB stores data in the exact same format as that. And what that means, it's super easy to work with on websites, because websites use JavaScript and JSON is inherently JavaScript. And the other thing is MongoDB is super light and is super easy to get running. So those are the three main reasons people use MongoDB. It's super popular as well. So if we just scroll down, we can see it says brew tap MongoDB/brew. So let's copy this line of code and we'll open our terminal again. So we just open our terminal and we run that one line of code. And what this does, it tells Homebrew to install the actual package of MongoDB. And once Homebrew knows what to install, then we actually install it using this line of code. Brew install MongoDB community at 4.2. So run that one line of code, give it a quick second, and it's installed. So now that we've got both MongoDB and Homebrew installed, the next thing we have to install is something called Node.js. And what Node.js is just an engine that allows us to run JavaScript. So if you just Google Node.js, it tells us Node.js is an open source cross-platform JavaScript runtime environment that executes JavaScript code outside of a web browser. So normally if we're running JavaScript, it's usually in a web browser or a website. But what Node.js allows us to do is run JavaScript outside of a web browser, which means we can use it for various different things. For example, you can make the server right now that we're going to make. You can also make like Google Home apps, stuff like that. You can make tons of things with Node.js, and all it really is just an engine that allows us to run JavaScript. So to get started on installing Node.js is super simple. So all we're going to do is open the terminal again, and all we're going to type is brew install node, brew install node. And once you click enter, just give it a quick second, it'll download and it's installed. Okay, so now we've got both MongoDB and Node.js. And if you want to test out that your Node.js has installed successfully, all you have to do is type node-v, and it says right here v14, and that we know we're on the 14th version and it's installed on our machine correctly. So now that we've got both MongoDB and Node.js installed, let's actually start working on the app and start building a server. Alright, so now let's actually start building a server. But before we do that, I just want to take a quick look at what text editor you should be using. So when you're making iPhone apps, you only have one text editor or IDE, which is Xcode. But when you're making websites and web services, there's a ton of different ones you can use. The most common one is Visual Studio Code, which is what I'll be using, and I recommend you to use as well. You could also use any other ones you like Notepad++, but VS Code is the most common one for software engineers who are web developing, so that's the one I'll be using as well. You can just go to the website and download it for Mac. So once you've done that, just make a new folder anywhere you want, and just title it anything you like. Let's call it server for Note app. Once you've done that, you can just right click it and click services and open with VS Code. Now this will actually open your folder in VS Code. So the first thing you want to do is you want to click the little button next to where it says your folder name. It's that little file button, which is new file, and just type in server.js. And what that means is it'll make a new file, which is a JavaScript file, which is why it's called .js. So once you've done that, again, right click server.js and click open in integrated terminal. And this will open a little terminal on the bottom where you can write commands. The first thing we want to write is npm init. And what npm is, it's like CocoaPods or Swift Package Manager. It just allows us to easily install other software packages and dependencies. And what npm init does, it actually creates a file that allows us to track what dependencies we're using and the version of it. And it actually means Node Package Manager Initializer. So just run it and it'll take you through a quick walkthrough. So you can click yes on the package name. And if it says it can only be URL friendly characters, just call it server then. Version's fine, 1.0. Description's fine, you don't need one. Entry point should be server.js. Test command, you don't need one. We're not making a Git repository for it now. You don't need keywords, author's fine, license is fine, and yes. And if you see on the top left, I actually made a new file called package.json. And this will allow us to keep track of what dependencies we're using and the versions of it. Now let's write another command on the bottom. We're going to write npm install express. And that'll actually install the express.js file so we can use it in our app. Same thing, we'll write npm install mongoose. And that'll actually install mongoose on our app in our folder so we can use it as well. So now let's go to our server.js file and we'll write var, or you could write const as well. Const express is equal to require, and in brackets in a string write express. And we're going to write const mongoose is equal to require mongoose. And one more thing, we'll write const, you can write var app is equal to express with 2 round brackets. And what that does, it actually creates an express object so we can actually use express in our project. So the first thing we're going to write here is mongoose.connect. You're going to write 2 round brackets and you're going to make 2 quotation marks inside that. And you're going to write mongodb //localhost/new db. And what this means is that we want Mongoose to connect to MongoDB, which is running on our machine, which is localhost. And we want to go into the new DB folder of that MongoDB. You can name this anything you want. You don't have to name a new DB. You can call it MyDB. But what it is just the database or the folder that all our data is going to be stored in. So after that, we're going to type mongoose.connection.once. So once Mongoose has made a connection, we want it to tell us that it's connected. So we can write open. So once the connection is open, we want it to call a function. So you can write function, 2 round brackets, 2 curly brackets. And inside the function, you can just write console.log, which is just JavaScript's version of print, connected to database. So what this means is once the connection is open, this function will be called, and what this function does is that it's going to print to our terminal that it's connected to the database. And we can, after that, we can write .on, and then we can say error. And then this is going to call another function. And this function actually takes in the error. So then we can write console.log failed to connect plus error. So what this means is if it's connected, it'll say console.log or it'll tell us connected to database. And if there's an error, the .on function will be called. And this function will be fired. This function takes in an error. And what's going to happen is it's going to print failed to connect. And then it's going to print our error. And if you want to make your code a bit cleaner, instead of writing all these function keywords, you can actually remove the function keyword and replace it with an arrow. So now you can have 2 round brackets and then an arrow, which is an equal sign and a right sharp bracket. So equals and a right sharp bracket like that, which will make the arrow. And then your block of code. And we can do the same thing right here, remove the function keyword. And then write equals with a right sharp bracket. And then this block of code. And this makes a bit more sense. It's going to take in an error. And then it's going to shoot this function, which is in this block of code. and this function is going to print failed to connect plus the error. So now that Mongoose either connects or it doesn't, and it lets us know if it connected or not, we can actually start working on the routes. But before we do that, we want to make something called a schema. And what a schema is, it's basically an object that holds all our data. So if you ever worked with core data before, you know that you define an entity, so you give it a title and you give it what it wants to hold. We have to do the same thing for our schema. So we have to tell MongoDB exactly what a note object holds. So for example, a note holds a title, it holds a note, and it holds a date. So we want to tell Mongo that it holds that thing and to save it in that format. So to do that, we're going to go back to our file directory on the top left. Again, click that new file button and write note schema.js. And this will allow us to actually define a notes object, so Mongo knows exactly what a notes object is and what data it holds. So in this file, we're going to write var mongoose is equal to require mongoose, just like we did in the last server file. And we're going to write var schema with a capital S is equal to mongoose dot, and it'll actually give you a list of things you can write. We're going to write mongoose dot schema. So once we've done that, we can actually define a new schema or a new data object. So we're going to say var note is equal to new schema. And you're going to write 2 round brackets and 2 curly brackets inside that. So now let's think what a note has. So it has a title, and the title is going to be a string. A note also has a date, which is a string, and it has the note itself, which is a string. So now we've got that. Now Mongo knows what a note object is. So it knows that a note holds a title, a date, and a note. So the next thing we're going to do is we're going to export this so that the server can actually see this schema. Because right now only the schema is only held in this file, note schema. And we want to transfer that file to the server. So what we're going to do is we're going to write const data is equal to mongoose dot model. And we're going to write 2 round brackets, and we're just going to call it data. And what is the data? Well, it's the note we made, right? So we can just write after data, put a comma, and write note. So what this does, it creates a data object, and that is actually a note schema. And the last thing we're going to do is we're going to type module.exports equal to data. And what this allows us to do is that it sends, or it allows us to access the note schema from the server.js file. So right now the note schema is only available to this file. So using the .exports keyword, we're able to send this to the server.js file. So if we go into server.js, let's type in var data is equal to require, just like how we had var express or const express is equal to require express. But this time we're going to write /note schema. So what the dot means is it tells the computer to look in the same folder as this file. So if you go back here, our file is actually located in the server for note app folder, right? So we're telling this file to look in the same folder, which is this folder, and look for the note schema file, which is right here. So that's how it knows where to look. So if you save both of those, now, and you can actually save by going to File and clicking Save, or you can click Command S. Now server.js has access to the schema, so we can start creating and saving notes. Alright, now let's actually start working on actually creating, saving, updating, and deleting some data. So let's think for a second. We're going to have a route to create a note. We're also going to have a route to delete a note. We're going to have a route to update a note. And we're going to have a route to fetch all notes. So let's think for a second. When we're creating a note, are we sending something to the server, or are we retrieving something from the server? Well, we're sending the note and the data we want to save to the database. So when we're sending something to the server, we call that a post request. because you're posting something to the server. Same with delete. Are we actually taking something from the server, or are we sending something to the server? Well, we're sending the note we want to delete to the database. So we're going to write post request. And what about updating a note? Are we sending something to the database or the server? Yeah, we're sending the new note, right? So this again is a post request. And finally, we have fetch all nodes. So are we sending anything to the database? We're not really, because what the server is going to do when we're fetching is going to go through the database and send the notes back to us. So this is actually called a get request because we're getting something from the server. So let's look back on the first one, which is creating a note. So we can type app, and the reason we type app is because we imported the express object and we saved it to the app variable. So we write app.post because it's a post request. And then we're going to write in the brackets, we're going to write /create. Because for example, if you go to google.com/search, it actually shows you all the stuff related to searches, right? So if we go to our app/create, we want to go to the part of our website which creates a note. And we're going to call a function, right? So you can give the 2 round brackets, the arrow, and the 2 curly brackets. But this function actually takes in a request and a response. So what a request is, it's actually data that the iPhone is sending us. So for example, what's going to be in the request object? Well, we're going to hold the note, we're going to hold the title, and we're going to hold the date. And that's all the data the iPhone is going to send us. And the response object is what we're sending back. For example, when we're sending all the notes back, we're going to send those notes in the response object. But that'll be more clear once we actually start working with it. So the first part, we want to create a new data object. So the first part, we want to create a new notes object. So we can write var note is equal to new data, right? And the reason we write data is because we imported it as data when we wrote data is equal to required note schema. And then 2 round brackets and 2 curly brackets. So if we go back to our schema, a note holds a title, a date, and a note. So we have to give it the exact same data. So it's going to hold a note, it's going to hold a title, and it's going to hold a date. Now to actually get what the iPhone is sending us, it's going to be stored in the request object. So we're going to write request.get, and then we're going to write note. Same for title, we're going to write request.get title. And finally, same for date, we're going to write request.date request.get, and we're going to write date. And the reason we write note, title, and date is because when the iPhone sends us this information, it's going to package the note, and on the top of the note information, it's going to tell us that it's a note. And on top of the title information, it's going to tell us it's a title. This will be more clear once we actually start sending requests from the iPhone. And this is a list, so after every note or after every line, you want to add a comma. Because this is actually an object, that's a list, so you want to add a comma after every line. So once we've done that, we've actually created a note object. And that object will hold the information the iPhone sends us. So now what we're going to do is we're going to write data, or we can write note.save. And that'll actually save it to database. It's that simple. But we want to know if it's successfully saved or not. So we're going to write dot then. And what dot then does is once it's saved, this dot then function will be called. And the dot then function will actually call another function. So we're going to use our function notation to create a function. And in this, we're going to say if, we're going to make an if statement, if note.isNew is equal to false, we're going to say console.log saved data. So what the isNew function tells us is that if the data is stored both on the server and the database, it'll return false. So what does that mean? Well, if the note is stored on both the server and the database, we know that it's saved to the database. But if isNew is equal to true, that means the data is only on the server, which means it failed to save in the database. So if it's false, we're going to say save data. and then we can write else. So if we save data, the opposite of that is not saving the data. So we can write console.log failed to save data. And one more thing in the is new is equal to false part, we actually want to tell the iPhone that we received the request. So we're going to say res.send saved data. So this will tell the iPhone that we successfully got the data and we saved it. And that's all this route is done. So now we can actually start testing this route and see if it actually works. But before we do that, we actually have to give our app a URL. Because right now there's no URL we can type in our search browser or the iPhone can ping, right, to access the server. So to do that, we're going to type var server is equal to, and you write app.listen, and the first argument you're going to give it is 8081, and the second argument is a string, and this is actually your network IP address. So if you open settings or system preferences, and you go into network, and you click advanced on the bottom right, you see that it gives you the IPv4 address. So just copy the IPv4 address, and close that, and paste it into the server. And what this means is any device on your network, so your iPhone, your physical iPhone, any laptops, any computers that are using your internet connection or your computer network, will be able to access the server. And the last thing we want to do is we want to call a function when it's running, right? So we can use our arrow notation, and we can just say console.log server is running. Alright, to get to our server, all you have to do is type, and I can write it as a comment here. You're going to type http / your IPv4 address, which is your string right here, :8081 / create. And the create comes from this route we created with the /create. So if any website or if any service pings up this address, it'll go to the create route. So we can actually test this now. So if I open my terminal using right clicking the server and clicking open an integrated terminal, we can just type node server.js, and we actually get this big error. So this looks kind of intimidating at first, but if you read it, it said server is running at the beginning. So that was the message we wrote right up here, which was server is running. And after that, it says failed to connect Mongo network error. So this was super helpful because remember when we wrote .on error and it says failed to connect plus error? Well, the failed to connect string is right there. And then the error is this big dump that we got right here. So what this really means is that we haven't started our Mongo client. And to do that, what we do is we go back to Chrome, and if you remember the website where we installed MongoDB from Homebrew, remember we had to use the brew install command? If we scroll down here, we see brew services start MongoDB community 4.2. So just copy that and open terminal and paste that line right there. And now it says successfully started Mongo community. And now our Mongo is running, our MongoDB is running. So what this error said was that Mongoose couldn't connect to MongoDB. But now that we've turned on MongoDB, if I exit the compiler or if I exit the terminal using Control-C, and I type node server.js, this time it should work successfully, and it does. You see server is running and connected to database. So now we can actually test our server using something called Postman. So if you just type Postman and click the first link, and what Postman is that it allows us to test our routes like our create and delete route, but we don't actually have to make a whole iPhone app first. Because what if we create the whole app and it works on the Xcode side, but we find out that our server doesn't work for some reason? So what Postman will allow us to do is send requests, and then we can debug our app to see if there's any problems. So if you scroll to the very bottom, it says download the app, and you can click the download button there. So once you've downloaded and installed it, just open Postman and click the new button on the top left. And once you click the new button, click the top left button, which is get request or request, create a basic request. And you can call this whatever you want. You can type, let's say, create route test, and then you have to give it a folder. So I've already created a folder called notes app demo, or you can just create one here. So just call it notes app, just save that, and it's saved in the folder, and click save. So now that we've got that, let's go back into VS Code and let's take a look at our address I gave at the bottom here. So the address we want to go to, and you can click that, you can type the address right in the middle here where it says enter request URL. You can type http://192.168.0.117, and this might not be the same for you. It's just the IPv4 address you copied earlier. And then you're going to write :8081, which is the port, and then you're going to write /create. And the reason you write /create is because we're accessing the create route. So when we're going to access the delete route later on, we're just going to change the /create to /delete. But right now we're doing the /create route. And the next thing you want to do is you want to change this get to a post. Because remember, we're sending something to the server, and the server says app.post, so you want to change that to a post request. And now what you're going to do is you're going to go down on the headers. So click the headers, and there's a key and a value. So you can name the header key note, and we can just copy paste it from here. Just call that note. And the next one is title. And the last one is date. And these have to match exactly what we told the server to look for. Because if I write notes, the server's only looking for NOTE. So if I send data with the title NOTES, the server doesn't know what to look for. So you have to make sure this exactly matches what we told the server to look for. And now we can just write test, and test. And these are just the values the iPhone's going to send. So later on, it's actually going to send a date, it's going to send a title the user wrote, and it's going to send the note itself. And now we know the server's running because it gave us the message which told us the server's running and it's connected. So now that we've got that, if we just click the send button, it should save the data. So we click send, and we get a message right here. It says save data. Also, our server tells us saved data. So now that we want to verify that it actually saved, so open your terminal and type in Mongo, and this will open the Mongo client so you can write commands and interact with your database. So you can type in the command show DBs, and this will give you a bunch of DBs or databases. What is the one that we're using? Well, we're using NewDB because that's what we defined when we wrote mongoose.connect. So type use NewDB, and it says switch to DB to NewDB. Now we can write show collections, and the only collection we have is datas, which means we have a bunch of data objects. Remember we define data here? Well, we have a bunch of these data objects, which is why it's called datas. So we can say db.datas.find with 2 round brackets. So db database.datas, which is when you wrote show collections, it'll tell you datas. That's where we get datas. And .find with 2 round brackets. If I enter this command, you can actually see that we've saved a test and test, which is exactly what we sent here. So we can send another one. So we can write another note, like for example, note this is the first note, title new note, and date, let's say Monday, July 17, right? So we send that. It says saved here, it says saved here, so we know it's saved. Again, now we can type show collections. It'll say data, so we write db.datas dot find 2 round brackets, and again you can see the new notes in the database, and it says this is the first note, new note, and Monday, July 17. So now that we know we can save data using the create route, we have to implement 3 more routes. So we have to implement a delete route, which is again a post request, an update route, and a fetch all notes route. So let's get started working on those. Alright, now let's get started working on the fetch route, and the fetch route is super easy. So underneath the create route, we can make the fetch route. So let's type app.get, because this time the server is going to be sending the iPhone something. So it's a get request, and the route we want to ping is fetch, and obviously every route has a request and a response. And use your arrow notation to create a function. And this one's really easy. We can write data, capital D, dot find, and we're actually going to give it 2 curly brackets. So this means we want to find everything in the database. If we want to find just, for example, not in this app, but if you had a certain app with, let's say, employees or companies, and you only want to find employees, well, you would tell it that you only want to find employees. But since we're using nothing, since we're entering nothing in the brackets, it knows that it has to find everything. And then we write dot then, and then once that dot then actually has another function inside of it. So use your function notation, and we can call this all database, or we can just say like database db items. So then we can write res dot send db items, not as a string but as the actual variable db items. And that's all the fetch route is. So what it does is when we ping, and you should add a slash fetch right there. What it does is when we go to the slash fetch route, the server looks through the database, finds every object, and then returns it using the response. So it gives us a response with every item in the database. So if we save this and we restart our server, so again, to restart your server, you click Option C and you write node server.js. It'll tell us it worked. So if we go to the address, which was http:// and then just look at the address you created, which was 192.168.0.117 /8081/fetch. This should actually show us every item in the database, but this time I'm not using the Mongo client. Instead, I'm using my web browser, because this is basically just a website. So this should work when I click enter, and there it is. Now I'm in my web browser, but I can still see the items I created. I had test, and this is the first note, new note, Monday, July 17, which is the exact same thing as what the Mongo client told us. Right here and right here, but this time I'm on a website using a web browser. So the iPhone is going to ping the website like the browser did to get all this data back. So now let's create the delete route. So I'm going to write app.post, and the route is going to be /delete, and every route always takes in a rec and a res, and then use your function notation right there. So what we're going to do is we're going to write data.find, and then if you just scroll down, you can see find one and remove. You're going to give it 2 round brackets and 2 curly brackets inside that. Now the way we're going to identify each node is using the ID property. So MongoDB actually gives the node a unique ID. So we can say that I want to delete this node with this ID, and I know I'm going to delete exactly this node. So there's no overlap between IDs. So for example, notes can have the same title. So if I say I want to delete note with this title, I'll actually end up deleting multiple notes. But if I say I want to delete note with this object ID, I know I'm only deleting this note. So we can say _ID is equal to rec dot get ID. Alright, and now if that fails, we want another function to be called. So, and this function is going to take in an error, and then use your arrow notation right there. And then you could say console.log failed, and then you can tell it the error. Now once that's done, you can write, at the end you can write res.send deleted. And this route should work. So we just save it, and I control C, I write node server, and I just restarted my server, so it's updated now. Alright, so now let's look at the note I want to delete. So if I use my fetch route, I can see I have this note right here, and it has this ID. So I'll copy this ID, and I'll go into Postman. I'll create a new request, and I'll call this delete test. That's the post request. And if you just write HTTP, you'll have a history of the last route we used, so you can just change that from create to delete. And now in the header, give it the ID and paste that ID. And now click send. It says deleted here. So when I refresh this, I won't see this anymore. And there it is, it's gone. So we know we've successfully deleted a note. So far, we can create notes, we can fetch all the notes we have in the database, and we can delete notes. So the last thing we want to work on now is updating a note. Alright, now that we've got adding, fetching, and deleting, let's work on the last thing, which is updating. So to update a note, we're going to make a post request, and the reason we're making a post request is because we're sending something to the database, and the server because we're sending the ID, and we're going to send the new note data. So I'm going to write app.post, and I'm going to name the route /update, and we're always going to have the rec and the res. And then this is going to fire off a different function. So let's put arrows and 2 curly brackets. Let's just make that big. Okay. So now we've got that. Just like we had find one and remove when we're deleting something, we also have find one and update. So I'm going to write data dot find one and update right there. Find by ID and update. But there's also one called find one and update. Either one works. I'm going to be using find one and update. So I'm writing 2 round brackets, and inside that I'm going to write a curly bracket, comma, curly bracket, and I'm going to have my error function. So just write err, arrow, and the 2 curly brackets. So the first curly bracket is the first object, which specifies the object we want to update. So in this case, we're going to put the ID in the first curly bracket. In the second curly bracket, we're sending our new data. So that's going to be the updated note. And finally, I just have my error function, which is going to fire something off if something goes wrong. Let's just start working on them. So in the first bracket, in the first curly brackets, I'm going to write ID is equal to rec.get ID, just like how we did for the delete route. We have to specify the ID, and we're going to send the ID. And now I'm going to write note. In the second curly bracket, I'll write note rec.get note, just like how I did in the create route. So you can just copy paste that and change this to title, rec.get title, and finally date is rec.get date. And it gives me an error, and the reason it's giving me error is because I don't have commas after every line. So make sure you put commas after every line. And in our error function, we're just going to write console.log failed to update plus err. So say failed to update, and it's going to give me the error, so I can fix it if it goes wrong. And finally, I'm going to write res.send. Let's write updated. So this is going to send back some data. It's going to send the message updated to the iPhone, so the iPhone knows the server has successfully done its thing. And this should be enough, so let's just save that. And now what I'm going to do is I'm going to go to my server.js. I'm going to click open integrated terminal. And I'm going to write node server.js. And I actually run into an error. It says address already in use 192.168.0117:881. And what that means is I already have a server running. So I try to run this server on the same address or the same URL as my previous server. So to fix that, all I have to do is go on the top right here, this little drop down menu, go to the one that says node, click on that, and you can see the server's already running. So all I have to do to turn off the server is click Option C. Once I click Option C, the server closes, and I can go back to my original window, and I can write node server.js, and it'll work. So if you run into that problem, make sure that all your other servers are closed, because you can't run two servers on the same web address. So now we've got that running, I'll go to my fetch route and see this is my data right here. So now let's see, using Postman, let's see if this actually works. So I'm going to go to Postman, I'm going to create a new route, and call this update route demo, and we're going to change that to a post request. The URL is going to be the same as all the other ones. We're just going to change this from a delete create or fetch to update. And now we're going to pass in some headers. So we're going to pass in an ID, we're going to pass in a title, we're going to pass in a date, and we're going to pass in a note. So the ID is the ID of the note we want to update. For example, I want to update the second note, so I'm just going to copy this ID, and I'll just paste it in here. Now the title, I just want to call this updated. I'll just change everything to updated so we know it's updated. And I'm going to run my request. I'm going to click send, and it says updated down here. So if I refresh this page, this note should have turned into updated, but this note should stay the exact same. So I refresh, and so if I send that, I actually run into an error. So I click send, and you can see it's not updating over here. And if I go back into my file, as you can see, it's not updating over here because the data is still the same. So I go back into my file, and I actually see it said failed to update null. So what does that mean? Well, it means that it doesn't know what I'm trying to update. And the reason that's happening is because I told the ID is equal to rec.getID, but when in fact it's actually called underscore ID. Because if we look here, it's called underscore ID. So the thing is, you have to make sure your keys and your values, so your keys are ID note title, and also the values you're getting from your server or your iPhone, which is going to be ID note date title, which is the same data right here. We have to make sure that these are case sensitive and exactly the same, because even if you're just missing like a small semicolon or a small underscore, your whole thing won't work. So I'm going to save this, and I'm going to restart it. So again, click Option C to turn off your server, and then click Node Server. And now it should work. So I'll go back here, I'll look at my fetch route, and I see my data's right here. So what I'm going to do now is go to Postman and try to send this same request again. And now it says updated, and I refresh it, and this time it's updated. So the problem was, it wasn't the exact same. I was missing the underscore, and if you miss a small detail like that when you're working with your database, you can run into some problems. But now that we're done the actual server side of things, so we have our create, read, update, and destroy routes, now we can start working on our Xcode and making our Xcode app interact with this.
Alright, so in this video, you've set up the web server and database and configured the endpoints that are ready for the iOS app to hit. In the next video, you're going to start implementing the Notes iOS app so that it's going to start sending and receiving data from these endpoints. By the way, this is Ali's first time teaching on YouTube, so show him some appreciation and support by leaving a comment below and giving him a thumbs up. Let him know if this video helped you, or if you want to see more iOS full stack development, or just give him some thanks. I remember in my early days, that feedback from you guys was extra crucial to help me carry on teaching. So let's show Ali some love. All right, I'll see you in the next lesson.